Hey guys, welcome to DSGN121 Week 2. We are going to begin this week by beginning to talk about Fusion 360 and talking a little bit more about the 3D space, how that works, and looking at the very basics of how to do sketching in Fusion 360. So if you have never used a CAD software before, this is a fairly typical layout of how it works, and Fusion 360 is just a really nice starting place because everything is very clearly labeled, and if you hover over stuff, it will actually give you a nice little description of what it is. So you'll see me relying on that occasionally just to give a better description of what some of these tools are. So for starters, we have here in our big main viewing page here, the viewfinder, we have our grid system that we're working on. And I believe I touched on this a little bit last week, but I'll just kind of reiterate it, that the general purpose of CAD is to fully define an object within a coordinate system. So very much like when you're plotting a graph that's in X and Y, and you are plotting different points and connecting those lines, we're doing that same sort of thing here, but just in a three-dimensional space. So right here, you can see that there's an X and a Y, and each one of these grid points refers to a specific set of points. So for example, right here, relative to what the scale is showing right now, this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and right there is 5, 5. So that's a specific point there. And this also extends into the third dimension, which is the z-axis, but we don't have a grid showing there. There is a way to do that, but I don't recommend it. I would recommend only being able to view your top viewing plane here, which is what this is. Over here in the right hand corner, you can see that there is a representation of where I am in my 3D space in case I get turned around. It becomes a little easier to make sense of things once you actually have some geometry, but until then you can rely on this to kind of see where you are. So for example, right here is the front, right, top, back, left, and bottom. So you can see all of those there. If you click any of these here, it will automatically shift the view to that view. So you can see here, I can select all of these different views. That will go up to the top there, there. And when you click the corner of the cube here, this gets you that isometric view that we were looking at in those orthographic sketches. So clicking that corner point there brings you to a nice isometric view. Okay, so X, Y, and Z are axes that we're working in. Everything that we do is based on that. This point here, where all of the axes collide, where they converge on one single point, that is referred to as our origin. And you can see over here on the left, we'll talk about this next here in a second, but you can see here that it's called origin. Do a little drop down on there. This right here is the origin point. So that is actually a point that you can click here that goes ahead and shows that that is in fact the origin point. Down here in the bottom right, you can see that it says origin point x0, y0, z0. So it's all working within a coordinate system. Everything that we're doing is basically just defining the geometry within this space. Everything here is just designed to be a simple, user-friendly way of achieving that. And we will begin with doing two-dimensional sketches and just kind of grasping the basics of that and slowly ramping up the complexity and learning about all of the different tools and how they work. So over here is the browser. And what the browser is this is how you actually view what it is that you are working on, in the sense of like a folder structure and kind of like almost like a timeline, but not quite. It's more of a, I think, yeah, it's more of a folder structure is a better way to look at it. So first thing we have here is the name of it. in this little symbol here. This symbol indicates that we are working on an individual component. Later on, we will be talking about assemblies, and assemblies are where there is a collection of more than one component. And I will talk more about that when we get to assemblies, but for now, we are just working on a singular component. Next, we have our document settings. Everything that we will be doing in this class will be in millimeters. And the reason for this is because the metric system is actually a very user-friendly dimensional system. And you will find as you use it that it makes a lot of sense, and it keeps your numbers looking really nice. The imperial unit system that we use here in the US is not as nice when you're dealing with all these 16ths and 8ths and 32nds. It's just kind of bananas. So in general, we're going to be using millimeters. It's just a lot cleaner of a system to be using. So that is in our document settings here. If you hit that button here, it'll bring up, you'll see a lot of these. We'll talk about these as they come up. But essentially, anytime that you are inputting any sort of information, there's going to be this like properties panel that pops up. So for example, this just popped up and it's saying I can change my units. For example, if I do a command here, it will also pop up the same place. So this is just essentially our working properties panel that will pop up, and every single instance of this is different depending on what it is that we're trying to do. Location of it will always stay the same though, I believe. So if I do here and I drag it over here and then I do something else, it'll pop up there. So this is our properties panel, and it is always going to be in the same spot. Next thing we have is named views, and this is just where we have our top, front, right, and what they're calling home. And home is just this nice isometric view there. And those are just default views. They do the same thing as if you were clicking over here. Next we have our actual initial geometry information, and this is all regarding the coordinate system. So in this folder of origin, we have the origin point, and then we have the x-axis, the y-axis, the z-axis, the xy plane, because it's going on the x and the y, the xz plane, because it's going on the x and the z, and the yz plane, which is going on the y and the z axes there. So that's kind of a fairly simple explanation of what is in this folder, and kind of a clear way to lay out the differing complexities. What I mean by that is you're first starting with a singular point, then you're moving to a line between 2 points, as in if I were to put one point here and another point here, that is what this axis goes along. And then when you have a series of 2 axes, as in the x and the y, you fill in that space with a plane. So we have our points, our axes, and our planes. And these are the bare bone structure of what makes up kind of the initial definition of some of our geometry. And we'll talk more about these, especially when it comes to construction geometry. And what this is this allows us to create planes, axes, and points based on our geometry that we actually have created. And it's very important that you learn how to use construction geometry, because it allows you to be able to create more additional features based on what you're working on. And if that doesn't make any sense, hopefully it will make sense later. As we add sketches and features, you will see them appear not only here, but also down here. So I'm going to create a very simple box, and this, I'm not going to explain everything that I'm doing right at the moment, because I'm trying to just illustrate a couple things at a time here. So first of all, I'm creating a sketch, and again, I will talk more about this when I talk about how to do sketching. But for now, all you need to know is I'm just creating a 3D object. So I've created a 3D object here. All 3D objects are based on, usually, unless you're creating a straight up shape, it is usually based on a sketch. And so over here, you can see that now beyond the origin folder, a bodies folder has been added and a sketches folder has been added. This is because we have created and added a sketch, which is located here inside of the sketch folder. And by me taking that sketch and turning it into a 3D object, I have created a body, which is this body here. And a couple things to note here. First of all, if you haven't noticed already, there's these little eyeballs. What the eyeballs do is hide and show. And you can do it at the folder level, or you can do it at the individual component level there. So in this case, in the sketches, my sketches folder is turned on, but my individual sketch is not. So if I click the turn the sketch on, you can see that blue line kind of show up there. That will actually make that show up or disappear. So that's the sketches and the bodies. So again, the browser over here is very much like a folder file organizational structure in which you can see as you create things, they will appear over here on the left. If I were to create a construction geometry that is based on that face there, you can see that a construction folder is then added where that new plane that I created is added, and so on and so forth. So as you add things, it will organize them for you and put them into folders so that you can easily find what it is that you're working on. All right, the next thing that we're going to look down at, comments is something I'm just going to glaze over real quick, but this is essentially when you're working in a collaborative environment, because Fusion 360 is a cloud-based 3D modeler. It's very heavily based on collaboration, and when I get closer to the end here and I talk about how to download it and get set up with our class and things like that, I'll talk a little bit more about that. But for now, you can work on a file with multiple individuals, and so you can do things like leaving comments and screenshots and attachments as feedback for other people that are working on it. So we're not really going to be using that necessarily. I could look into playing around with it for some grading purposes, but I have not done that at this time. Next thing is down here at the bottom, we have a timeline. And what the timeline does is this allows you to not only see the order of operations of how we got where we got, but also be able to go back and edit previous features as well as inserting new features in the past. So it goes from where we started to the last thing that we did. So the first thing I did was create a sketch. Then I extruded it out into this box. Then I created a construction plane. So if I take this little bar here, I can actually scroll back to before I created that plane, and you'll notice that the folder from construction disappeared. And I'll go ahead and scroll back again, and then you'll notice the folder from the bodies disappeared, and my sketch is still there. And if I scroll back before that, then we take it all the way back to where we started. Now let's just say after this extrude, before I created this plane, I, for whatever reason, wanted to actually move this a little bit higher. So I did a secondary push-pull. Then I create that construction plane based on that face. So that's just an example there of wanting to change something. Or if I really wanted to add, if I wanted to add in like a completely different feature, I could go in and so let's just say I did something like that. I can go back in time and add in that feature, and my construction plane that's based on that face is still there. That's just a quick example there, just showing you how you can go back, edit stuff. So also, if I wanted to edit the length of this extrude, I could right click it, edit the feature, change the distance to 50, and it will go back and update and reload everything based on that. Same thing with this one. I can edit the feature, I could change that, and it will go back where we just were, but it will have updated that. I can even go back, edit my initial sketch, make it a different shape. And in this case, I believe I've done something where, yeah, so I made my initial sketch smaller than my feature down the lane there. So it actually completely eradicated it. So I'll have to come back and adjust this one, and then that will make that update. So that's something also to note, is what you do in the past affects the future. No, I'm not talking about time travel, but could be. In this case, it actually does work like that in the sense that if you adjust this, in the future, this one is going to be cutting a certain amount of distance, and if you make the sketch smaller than this cut, then this cut will no longer, it'll cut through the entire thing. So we will be talking later about how to combat this kind of stuff and create quote-unquote time traveler proof geometry. Well, I should patent that. That's a great idea there. But basically, it's going to keep it so that if I were to make a change to this, this will always be the same amount that it's cutting off, and we'll be talking about how to do that. But in general, all you need to understand for the most part here about just our initial walkthrough is just, this is your timeline. You will be using it a lot. There are a lot of different things you can do here: deleting stuff, moving your marker, editing the feature, and for the most part, you will be going back to this quite a bit as you develop stuff. One thing that I didn't say off the bat that I usually lead with is just that Fusion 360 is a parametric modeler. And if you are unfamiliar with what the terminology means, parametric just means that everything is assigned a value of some kind, and when I change that value, it will recalculate the shape that it's supposed to be based on those values. So for example, in this case, it's parametric because I can go back in, edit this, and make this a 60 instead of a 50, and everything updates. There are other modelers such as Rhino, which you will be learning if you're a product designer. Rhino is not a parametric modeler, meaning if I make something 50 millimeters and then I continue to do other things to it, I will not be able to go back and change that height later because it doesn't save, and the model is not tied to mathematical models. So that's just a little bit of what makes this work. You will find that each type of modeler has its pros and cons, and there are things that you will like about Fusion. There are things about Rhino that you will like more than Fusion. There are things in SolidWorks that you will like more than either of these, so on and so forth. Every software has its strengths and weaknesses. Down here at the bottom, we have our kind of view tool set. And initially here we have what allows us to select something here and say if you want to be able to orbit, like so, and then I am clicking with my left mouse button here, or a constrained orbit, which is the default. And what constrained orbit does is it kind of tries to keep it flat relative to the Earth to give you a little bit easier time navigating. Look at, if I click that, essentially it makes the whole view normal to that. We talked about in orthographic how we don't have perspective. This is all in that same viewing plane. So therefore, when I click this and I say look at, it will do the same thing, and it makes it nice and flat and able to be worked on. The pan tool is where you click and drag and it will move like a panning motion instead of an orbiting motion. Zoom will allow you to zoom in and out. Zoom window is where you drag a window and it will fill in to whatever that window is. So if I zoom like that with my zoom window, it'll zoom all the way in until that window's my whole window. Now, something you're seeing me and hearing me do is I'm actually able to do my orbiting, my panning, and my zooming all with quote-unquote hotkeys or shortcuts. Instead of going down here, clicking this, panning, clicking this, orbiting, clicking this, zooming, I can actually do all of this with a combination of my mouse and my keyboard. So I believe I actually might have mine set up slightly different than default. I should probably check that. Where's my preferences? There it is. I have my pan, zoom, and orbit shortcuts for SolidWorks because that's the one that I use the most. I use SolidWorks in my day job, so I leave it in SolidWorks. I believe yours is actually Fusion, so let me just change it so that I don't tell you incorrectly. So default, your left mouse button is for selecting. And in case you don't know the difference between selecting left to right and right to left, I'll explain that real quick right now. Basically, if I have, just go ahead and create another box real quick here. If I have two objects here and I select from right to left and I just touch both of them, it will select both of them. If I go from left to right and I fully encompass one of them but only touch the other one, it will only select the one that's fully encompassed. So very simple explanation of that. Basically, if you want to drag from left to right, you have to fully encompass it. If you go right to left, you only have to touch it. Just like that. Anyways, back to my shortcuts here. So if you right click, it does nothing except for bringing up this little shortcut bar here, what allows you to select some shortcuts. And if I click and hold my middle mouse button, it will automatically hold, or pan, sorry. It will pan if I hold my middle mouse button. If I hold Control and middle mouse button, nope, not Control, Shift. Shift and middle mouse button will allow me to orbit like this, and then my scroll wheel on my mouse will allow me to zoom in and out. So zooming in and out, panning, holding Shift, and orbiting. Okay, so that is the Fusion defaults, and I'm going to go ahead and put mine back to SolidWorks because it just helps me keep things straight when I switch between softwares. So I'm going to change it back to SolidWorks. Okay, cool. So we're back to what I'm used to. Next we'll talk about display settings. This has to do with how things are viewed here in the display. So visual style, if you do shaded, it will get rid of those actually darkening the edges. I recommend leaving it in shaded with hidden edges or going to wireframe. Sometime shaded with, what is it? Shaded with hidden edges is also useful at times. I've used this one quite a bit. And this will allow you to still see the shaded, but also see the hidden lines through it. We talked about this with the orthographic sketches with hidden lines. Basically, it's just saying those lines do exist. They show up as dotted lines versus these solid lines. It's just now we're viewing that in a 3D space. Wireframe will get rid of the shaded faces and just give you straight up lines. And it'll do the same thing here. It'll kind of give it a wireframe shaded look, but it's with hidden edges and then visible edges only. So different options there. For the most part, we'll be working with 2 or 3 of them. I'll just go ahead and leave it with the normal shaded with the visible edges only. Our mesh display we're going to leave. Our environment here has to deal with the background here. If I do dark sky, we'll change it to a dark view there. Gray room, photo booth, tranquility blue, infinity pool. So all different, depends on your preference, what you like to see. If you notice here, in this case, this one is only an infinity pool because it's only down here where you're working and not everywhere else, versus the gray room, for example, which will just be gray all the way around. Anyways, depending on what your preference is, you can set it up how you want. This case, the environment doesn't really matter that much. I leave it as photo booth just because this is usually best for instruction, at least, because then you can very clearly see what I'm working on. Object visibility, we won't really mess with this too much. Basically, this just allows you to turn off seeing different things that you might make visible. Camera, orthographic is what we're dealing with. Again, I can just show you here real quick. Perspective, and how when I look at an object from straight on, like so, and I were to turn on my hidden edges, notice how you see these extra edges here now. This is what the difference is between perspective and orthographic if you didn't understand it from before. These do look more realistic in terms of how we perceive things in reality. And this is a good thing to do for renders. So when you render stuff, rendering in perspective is always preferred. But when you're modeling, perspective is not helpful whatsoever. So you want to make sure that your camera is set to orthographic, because that way when I view this, I'm not getting all those extra lines and I'm viewing it as a straight on view. Ground plane offset, we're going to leave that as is, and that is all with that. We'll move over here to our grid settings, and this here is the grid, and the grid also shows up anytime that you're doing sketches. Currently we're showing our layout grid, and we want our layout grid lock to stay active, and we want snap to grid always. The reason you want snap to grid is just as you are dragging lines to points, it makes it a lot easier to create stuff if you're not just arbitrarily placing lines willy-nilly. So leave snap to grid on. Under your grid settings, in this case we're adaptive, meaning as I zoom in, you can see that it perpetually splits until it gets to a certain point, but it will keep splitting otherwise, which is what you want. So just leave all those as default. And next we have viewports. If you click multiple views here, you can see your top view, your front view, and your right view. As always, and when you move in this view, you can see it in perspective. Moving in this view, now it's changing all these to perspective. That's probably because I have mine set to SolidWorks default, which SolidWorks default is orbiting. So in here, it actually makes more sense to use the fusion. Anyways, I don't necessarily recommend using the 4 viewports. That is something that is used in Rhino, but that is a completely different class, so we will talk about that then. Otherwise, I would just say go ahead and make this one view and learn to work in the singular view. So that basically covers our main objects here in the viewport, and we will now move on to talk about sketches. I will very briefly just kind of brush over all of the different tabs and things and how that kind of works, but we will not be focusing in depth on those until we get to those. So for starters, we are going to be heavily working in the create section here. And I guess before I even get to that, let's start with the far left, which is design. This has to do with the environments that you're working in, whether you are rendering, making an animation, making a simulation, making computer-aided manufacturing, toolpaths, things like that, or creating drawings. We will be primarily working in the design environment, so just go ahead and leave it in design always. The solid section is where we will be spending most of our time. Solids have to do with the fact that they are fully enclosed, fully three-dimensional solid objects. When you go to surface, you can actually create stuff that is only a surface, basically meaning they do not have to be enclosed solid objects, if that makes sense. So best way to describe that is between a point 2 points is going to be a line. A closed network of those lines is going to be a surface. A collection of multiple surfaces is going to be a polysurface. And then when that is fully enclosed, that will actually make that a solid. So that's the difference between those two. Sheet metal is where you make particularly, specifically sheet metal. And again, that's a whole unit thing that we'll talk about later. And tools, these are actually found on some of these other ones here as well. The inspect, insert, select, those sort of things, those are also found here. Inspect, select, and there are some other things that are included in here. Utility, rebuilding, creating 3D prints. There's a bunch of other stuff under inspect, but again, this stuff is all found over here under inspect as well. So tools is just kind of like a dedicated place to find these specific commands here. So again, we'll be sticking over with solid, and we'll talk a little bit about creating, modifying, assembling, constructing as we move along. For this week, we will be only focusing on the creating and specifically sketches. So besides create a sketch, on the create tab, you have a few other options that we will look at more deeply next week. But essentially, you have the basics that you're going to be using a lot, which are extrudes, revolves, creating holes, which again, I was trying to show that briefly, but it takes a little bit more information to make those happen. Patterns, and then freeform is like a completely different thing that we'll talk about later. And if you click this, it'll bring a drop down that gives you more options here, besides just the ones that you'll be using the most. So besides that, we have a new component, which again comes into assemblies, which we will talk about later. Creating a sketch, again, extrude, revolve, sweep, loft, rib, wed, emboss, hole thread. And then here you have standard geometry that you can create that will base itself off of prompts that it gives you instead of sketches. Patterns, mirroring something, so that means taking something from one side, using a plane and creating an exact mirror of it on the opposite side. Thicken, boundary fill, all of this stuff down here we probably will not be using at all. But yeah, that's all under the create tab there. And again, this is all about creating initial geometry. And then the next tab is modifying existing geometry. So modifying something that you've created. And under modify, we have a bunch of different ones here as well. Again, these will come up more in a couple weeks. And assemble, again, that's what has to do with assemblies. Construction, I already talked a little bit about that. Inspect tools, the main one that you'll be using is measuring. And under insert, later on when we get down to probably about the project, we'll talk a little bit more about the insert options here. And selecting here, we're pretty much just going to leave this as default. So with that in mind, we can look at a couple other things before we jump into sketches. Firstly, let's talk about our undoing and redoing. If you have never used software before in your entire life, you are unfamiliar with the concept undo. It basically translates across everything as Control-Z. So Control-Z or Command-Z if you're on a Mac will undo whatever the last thing was that you did. So I can keep doing undo here as long as I want until we get all the way back to 0. And it'll just undo, 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 undo everything. So undo is a great tool. If you've messed something up or you want to go back, you can hit Control-Z until you are back to where you want to be. And up here, you basically just have the option to see what you've done in a history. And in this case, you can undo and redo to go back to where whatever it is that you were doing. The save tool is going to save it out. The file will just basically just saying a new design, saving it or exporting it if you're using a different piece of software that you want to use something from this from. And that brings us to just talking a little bit about how Fusion works in the terms of saving files and using the cloud structure. And I will segue into talking about how to download it and create an account. And then after that, we will talk about sketches and your homework for this week. So Cloud-based basically means that nothing is saved locally. It's all saved in a cloud. If you hit this little plus button here, this will give you a new document to work on. And they are untitled until you hit the save button. And then once you've hit save, you can save it in a location. And that location is determined based on what group you are working in and what folder within that group that you would like to save it, or project within the group, and in the project, which folder. So in this case, I am going to be inviting all of you to my class group, or I guess they call it teams. Sorry, that's my bad there. They call them teams. When you start up Fusion for the first time, you will be asked to create your own team. Besides your team, you also have your single user storage, and you need to make sure that you are in the single user storage when you join my team. And then when you join my team, you will have the option up here to select class. So here it'll switch into my single user storage, and then when I hit class, it'll change me back into the class team that I am a part of. And again, all this is accessed by hiding or showing this data panel here. So make sure once I've sent you an invite, and you will need to message me, and I will create something in the Teams group in order for you to let me know. But I need to know what email you created this with. I'm going to assume and recommend that everybody in the class use their Walla Walla email. That will make it a lot easier for me because I can invite you as soon as later this week once you've made your accounts. So inside of the class, we have our projects that we're working on, and we are going to be working in the DSGN121 Winter 2021. And within that, I will be creating folders for each of our exercises. And so as you do your exercise, you will want to save your exercise within the correct folder. And so I believe by me adding you to the team and then adding you to the top level of the DSGN121 W21, you should have access to all of the folders that I create as we go along. If for whatever reason you're unable to save in a correct folder, just let me know and we'll try to make sure that we get you access to that. So that's kind of how that works. And again, this is all based on cloud, so it's not actually saving it to your computer, meaning you can actually download Fusion just about anywhere and log into it and be able to access your files from anywhere. So very cool in that regard. And with that, I'm going to talk a little bit about here of how to actually download it. So what you're going to want to do is go to your favorite browser and go to Google, and you will be Googling Fusion 360 Education. And the first result that comes up should be the correct one, which will be Fusion 360 for students. And what you're going to do with this is you're going to click the Get Fusion 360 Free. And if you have not created an Autodesk account, you will need to create one. And you will have to click the Get Started here. And then under here, you'll need to do student, university, put in your information there, go through all the prompts until you have certified that you are in fact a student. And again, make sure that you're using your EDU Walla Walla login for that. And when you're all done, you should be able to download Fusion onto your computer and then just log in using that account and then launch it. So it's very simple. Just make sure you're Googling Fusion 360 Education and downloading the full version with your Autodesk account, Autodesk Education account. Okay, so it's fairly straightforward. Let me know if you have any problems with that, but make sure that you get that downloaded as soon as possible this week so you can start working on your homework for this week. So for the sake of showing you how to do your exercise for this week, I'm going to be doing a couple of examples myself and kind of explaining through how sketches work in the meantime. So for starters, starting with my Untitled document, and the first thing I'm going to be doing is creating a sketch. When you click that button, you get this little interface here that shows up, And what this is asking is it's asking you which plane would you like to sketch on. For a purpose of our assignments for this week, everything should just be on this top plane. So all you'll need to do is just make sure that you're selecting the top plane. It will go normal to that top plane, and we are ready to start sketching. A couple things before we get started. Let's just talk about what we're seeing here. First of all, we are seeing the grid of the X and the Y with the values here in millimeters of where everything is located. Over here we have create modify again, but this time they are directly relating to a sketch, which you can see here in the blue highlighted tab. So we have creating lines, 2-point rectangles, circles, splines, mirroring an object, dimensioning an object, and then if you do a drop down, you have even more options than that for other type of line geometry. Then under modify, you can do a fillet to a sketch where you are placing an arc between a specified radius at the intersection of two lines or arcs, which we will do a couple examples of with some of the example exercises that I have here. Trimming an entity, extending an entity, breaking an entity, changing the scale of the geometry, offsetting. And then here are constraints, and constraints are a little tricky to understand at first, but as we start to use them, hopefully they should make sense. So what constrain does is it allows you to assign rules to each of the individual entities that you are creating in order to better define them. And the goal of every single sketch that you will make is to fully 100% define the sketch. So what do I mean by 100% defining a sketch? Well, I mean if you draw a rectangle and you create it like so, and then you finish your sketch and you create some geometry based on that, you have a incomplete, undefined sketch. And you can tell this because there's a little pencil on it right there. So when I right click this to edit it again, and I go in and I click my sketch dimension tool, I can actually add in a dimension. So in this case, I'm going to say this is 100. I'm going to type that in, 100. And I want to know how tall it is, and I'm going to say that it is 50. And notice how my lines turned from black, or from blue to black. That is also an indicator of that you have defined a specific set of lines. So in this case, if I were to click and drag this, you can notice that I can move it freely in one direction, but I cannot move it in the other because I've already defined that. So I need to make sure that both dimensions are defined. So I'll go ahead and make this 50. And then you'll see the whole thing turns black and the pencil has turned into a lock. If you do not have that lock on your sketch, on every sketch that you create, you will get markdown points. This is the biggest and frankly one of the only ways to lose points in this class. Make sure that you are fully defining all of your geometry as you go along. This is just best practice to get into immediately, and I am very firm about that. And basically with every exercise and thing that you work on, you will get marked down if I see undefined sketches. And for however many entities it takes for me to fully define it, I believe each one of those entities marks you down a 0.25 of a point, which may not sound like a lot, but when you're dealing with a 10-point assignment and you have 7 errors and you have 6 sketches and each of them has 2 or 3 errors per sketch, it adds up very quickly to a not so good grade. So make sure you're fully defining stuff. And again, I'll talk a little bit more about the dimensioning tool here in just a second, and talk about how to fully define stuff, because that is what's really critical. So the constraints here allow you to give the lines constraints. So for example, if I make this line crooked, like so and like that, and I want this to be straight up and down vertical, I can click the line, click horizontal vertical, and that will make it whichever it is closest to. So in this case, this line is probably closer to being horizontal than it is vertical. So when I click it, it will change it to horizontal. And in the case of this other line, it was closer to being vertical than horizontal. The only reason I'm saying that is because this tool is called horizontal/vertical, and whichever one it is closer to, it will make it either horizontal or vertical. This is very regularly used because this is, frankly, a lot of the geometry that you'll be doing is going to be relative to the coordinate system. It's going to be vertical or horizontal. If I were to draw this line, and you can notice here as it shows those degrees, if I make it actually horizontal and I select a point and then I select another point here, you can notice that it adds in these T's. And if I were to draw in a line adjacent to it here, you can see there that it says that those are parallel. If I go here, those are automatically inferred constraints right there. And that is based on when you make things that are horizontal or vertical. So in this case, this symbol means perpendicular. Hopefully I don't have to explain all these geometry terminologies too much. They should make sense, but basically perpendicular is where this line is perpendicular to this one, meaning that this corner is 90 degrees. Same thing here. This one is 90 degrees. Parallel means that these two lines are traveling in the same angle, in the same direction. And again, this line was created with a vertical constraint. So all of those have those constraints so that when I move them around, they at least know the angle at which they are. The next one that we'll talk about here is coincident, and this is very, very important and will be used a lot. So make sure that you understand what's going on here. What coincident means is it means that it is going to be occupying the same space. And in this case, they might have a better description of it: constrain the position of 2 points or a point in a line or curve together. Basically what that means is, notice how this point can go wherever it wants at the moment. If I constrain this with a coincident to the line, notice how it automatically added that when I dragged it to it. What that means is now that line is stuck, or that point is stuck on that line no matter where that goes. If I make the points coincident, like so, if I can, let's see if I can add it. There it goes. You can see there it's got two coincident constraints now. That means that where that point is, those 2 points will always be in the same spot. Okay, I can do the same thing over here. So I can drag this and this point, make those coincident, just like that. So all coincident is basically, and it applies not only to lines but also to circles. So if I had a circle like this and I wanted a line that was on that circle, anywhere that circle goes, that point is staying on that circle. So coincident is used a lot. You will see it regularly, and we will even be talking about some advanced uses for coincident at a later point. Tangent basically just means if I have a circle here and I want it to be running along the same curvature, sorry, the line here to be running along the curvature of the circle here, and I make it tangent, it will then always be along that, like so. And I could add this side over to here and make those tangent. And something I'm not saying that I'm doing, but I am doing, is in order to create these constraints, I am clicking one object, then I'm holding Control or Shift, clicking a second object, and then applying the constraint. So make sure that you are doing that if you're having trouble making it work. If I wanted these two to be the same length, I could do an equal. So I could say this one, shift, this one are equal. When I drag one, the other one should move as well. And in this case, it's doing a little funky business because I have that extra point down there. So here's another use case of the horizontal vertical, is I can take this point, hold shift, click that point, and I can make those points horizontal to one another. Meaning here they are now occupying the same axes there. Okay, so that's another important use case of the horizontal and vertical. Parallel, we already saw an example of that, and we talk about that. Perpendicular, we've seen that here. Fix, unfix, as a general rule, just don't use this. Basically what this does is if I were to select all of this and fix it, it will give it the illusion that it is fully constrained, but it is actually not. So what that means is now when I click and drag, nothing will move, which is great, but nothing is really defined either. So as a rule, don't use fix or unfix. Midpoint is another one that's used a lot. And what this is if I were to create a line and I wanted this line to exist at the, or be coincident at the midpoint of this line, as in the middle of, from this point to this point, the middle of that is right here. The reason I know that is because the little midpoint symbol shows up, which you can see there in blue, the little triangle. You can also apply it by clicking midpoint, clicking the point, clicking the line. And that will also give you a midpoint constraint there. Okay, here you have concentric. What concentric means is when you have multiple circles, if I want the center lines, or sorry, the center points of both of these circles to be exactly the same position, I can select both circles, make them concentric, and they will share the same center. So now they are scaling together there. Collinear, what that means is if I have a line like so, and I want this line to be going the same, on the same axes as this line, which in this case I understand that this is horizontal. If we wanted to, let's see if I can find the, oh, there we go, perpendicular. So I'm going to delete that perpendicular. And yes, you can click any of these and delete them if you need to make edits. So let's just say this. If I have this at an angle like so, and let's just say I defined that angle. So I'm going to click those two lines. Again, we'll talk about dimensioning here in just a second. If I wanted this line to continue along the same trajectory as this line, I will hold shift, click both, and select collinear. And so what that will do is that will make them follow along the same axes. Okay? And symmetry is where you use a construction line, which is something that we'll talk about here in just a second with our construction. I guess we're basically going to be talking about it now. But basically, when you create a line, and I'll select the construction option here in our properties panel, and I'm going to create a line that goes from the midpoint straight over. What I'm going to do is I'm going to select this line, hold shift, this line, and then my dotted construction line, and I'm going to click symmetry. And what that will do is that will then make it so that this line and this line are always the same distance away from one another relative to this construction line that I've created. Basically what this is it's creating almost like a dynamic mirror of whatever the object is on one side to the other side. This can be done with even things like objects like a circle. So if I create two circles, Notice that these are construction. I can change that just by selecting them, going over here to my options and deselecting construction. I can make these equal. And what I can do is I can select them in this line and make it symmetrical. So now, no matter where one goes, the other one mirrors it on the other side in a symmetry fashion. Okay, so that is how symmetry works. And again, the main thing that makes this work well is that you're using a construction line. So what construction is it is geometry that does not affect your actual end result, I guess is a way to put it. For example, if I were to extrude out, and I'm going to go ahead and just delete this stuff up here just to make this a little bit more simple. I'm going to get rid of that line, and I'm going to take these two, hold them, make them coincident. If I were to take this and extrude it, and I select this here to extrude, and I get that shape there, that is what happens when you are using with a construction line going down the middle. However, if I were to go in, I'm going to edit my sketch. If I were to change this to a non-construction line and then finish my sketch, when I were to select this, it now is split into two profiles, which, yes, if you select both profiles, you will now have the ability to have the same extrusion, but it is using two profiles instead of one. So notice how that splits it up. And again, I could go in here and I can click this, change it back to a construction. I can add in, and I'll just do a really extreme example here, but I could add in as many lines as I want that are doing whatever they want. I could even have lines that are out here, but as long as they're construction, it won't affect the actual profile. So we use construction lines to help us define whatever it is that we're doing, or if we're trying to reference something else that it's going to be relative to, but we don't actually want that to show up in whatever it is that we're trying to create. So we do use construction geometry quite a bit. So be familiar with selecting it on and off with the properties panel over here. Okay, other things to look at over here in the our properties panel, in this case it's the sketch palette, is besides construction we also have our look at, which is in case that you're dealing with a 3D sketch, which we'll be looking at later. Most everything here we will just leave as default. So the most important thing that you'll be dealing with is just the construction. So that pretty much covers most of the basics of sketching, and obviously there are more types of lines that we haven't looked at, and we haven't looked at any of the modifying yet, but I will begin to show you those as they come up in my exercise example here. So we are going to be creating this simple sketch here, and you will be getting similar ones to these for your homework for this week. So if you do have any questions, let me know. But for now, I'm going to be doing these two examples right now. And just pay attention to how I use the dimension tool, how I use the constraints. And yeah, if at any point, again, you can just come back and reference this video or ask me questions if you have any questions on fully defining your sketches for this week. So we'll be working with this object here, and the way that I usually like to go about creating stuff like this is I initially sketch out what I see, and then I come in and I define it later. I don't draw something, define it, draw something, define it, draw something, define it. If I were to do that, it would take me all day to get through stuff. So what I do is I sketch the whole thing, and then I come back and I define it. So I'm looking at it, I see what I see. We've got this lower line here, two lines here, angle, straight, angle, two circles. Okay, so I'm going to draw that. Your placement of your sketches is very critical. it always needs to have some sort of relation to where the origin is. If you do not, so for example, if I do something like this, and again, I'm doing an example instead of doing what I said I was going to do, but regardless, it's all in the name of science. If I define this, it still shows blue. And the reason it shows blue is because I can grab this corner and I can move the whole thing around relative to the origin because it doesn't know where it is. So I could either dimension this point relative to the origin, say, oh, it's 26 away, and it is 12 in that direction. So now it's fully defined relative to the origin. And in most cases, you won't be doing this. Instead, what you'll do is you'll need to click some point and drag it to the origin and snap it and make it coincident with the origin. And that will fully define it. So if for some reason you've done all of your dimensioning and it's still showing up blue, just make sure that you have some point of it snapped to the origin. Now, the placement of this is totally up to you. In most cases, I do one of two ways. I either will line up the what we'll call the leading edge relative to the origin, or I will actually, and I'll just click this here, see if I can delete those. Oh, there it is. Get those to be coincident again. I'm just going to make that flat, and I'm going to make these two coincident. Or what I would normally do in a lot of cases, and again, this is not always, just something to be aware of, but I actually create a midpoint construction line, and then I will snap the middle of it relative to the system here. Again, I don't always do this, but in some cases that is a method that I go about. So you will see me using both in actually both of these examples here. I'll do one where I do one to the right, and then the other one I'll be using a construction line down the middle. So with that in mind, let's go ahead and sketch our initial shape. So I'm going to again start at the origin, and you can see my line here is construction. I can actually just go over here and change it mid-sketch to that. And I'm going to go here, up here, over, down, and I think it was straight down. Or was there a flat portion? Nope, straight down. Straight down and over. And then within this, there are two circles. So I'll just get my two circles placed. And there is my initial sketch. Okay, so now I'm going to start defining it. And usually the first thing that I will do is look for the initial outside dimensions of the object and look for anything that might be using the same dimension. So for example, I can see that the 44 and 44 are the same, meaning this line and this line are equal. This here, you can see a 33 and a 33 from two different angles. We can do that, that's fine. And if you notice, there's no dimension for this line. The reason for that is because if we know that this distance is 45 plus 83, and we know that this bottom line is 120, we can infer what this line's length is relative to that. So you will see this on your drawings. Not everything is defined because it doesn't have to be. In order to fully define something, we only need to put as much information as needed without putting duplicates. So I will go ahead and take this line and this line, make them equal. And then I'll go ahead and take my lower line and I'm going to go ahead and make this 120, as that will give us our kind of scale that we're working with. And you can see here that I created something that was much smaller than what the example is. So I'm going to kind of just stretch it to make it look a little closer to what our actual size is going to be. And the reason for that is just because as I define things, it'll make it jump around less. And I believe that these were 44. So I'm going to type in 44. And the way that I'm dimensioning is you can either select lines or you can also select 2 points. So for in this case, I'm going to select this point, and I can drag up or to the left, and you can see there how my dimension moves, or I can drag out parallel to define it. So in this case, I'm going to go straight up, and I'm going to make this 33, and I'm going to drag straight out to the left, and I'm going to make this 33. And this line, I believe, was 45. You can see there now our outside is fully defined because it's black, but our circles still need to be defined. Now, in terms of how I place my dimensions, I actually place them as if I was trying to make a drawing. And the reason for that is because it makes it a lot easier and cleaner to use later on if I need to come back and adjust stuff. So, for example, I don't place this dimension here. I don't have it like this. I don't like having things like all chaotic and interfacing with stuff. I try to keep my stuff very clean and organized, if at all possible. So I'm going to drag these out, make them nice and readable. Make sure I have some room under this one because I'm going to add in the location of these circles. And again, we're now that we've defined this object, I just need to reference where these circles are located relative to this object. So for example, I could say where this is relative to this side because I know where that side is, or I could say where this side is, or sorry, where this point is relative to this side. And in this case, I believe the drawing gives us that dimension, which is 36, and then the other one will be 84. So we'll type in 36, select the other one here, make this one 84. And when I want to make a diameter size, I just need to select the circle itself, drag out the dimension, type in, I forget what that one said, was it 36 as well? 36, enter. And again, I'm editing these dimensions. If for whatever reason you just want to define it and then come back and fix it later, you can always just hit enter. Just like in the same way I can dimension where this is relative to the bottom. Just hit enter relative to the bottom and hit enter. Or in this case, I can actually drag it out this way, make it a little more legible. And then I can come back here and say, okay, that needs to be 20, that needs to be 36, and that needs to be 20. So 20, 20, 36. There we go. And so that is a fully defined sketch. You can see that everything is turned black. If I try to click with my mouse and drag any part of it, it should not move. It should all be nice and secure there. All right, so that'll be the first sketch, and I'm going to just hit the finish sketch, and I can name this as exercise 1. And then I'm going to create a new sketch. And the reason I'm doing this is because I'm showing you how I would like you to lay out your homework for this week, which is to turn in one file that contains multiple sketches in it. So I'm going to create another sketch here, and the plane that I want to use is the same one as before. So I'm going to click that same plane, and I'm going to begin to sketch my second one here. So my second one here, notice how it has symmetry. It is symmetrical down the middle, and you can see that it's also got some of these lines here. Those are indicating that those are circles, and it's showing that the center point of those circles, where they are relative to one another, as well as relative to the center line. So those markings there are implying those two different things, that this is as a center line and that it's symmetrical relative to that, and that these are the centers of these circles. Okay, so this one's kind of an interesting one. It's got a lot more curves going on to it. It's got a slot in it. It's got some concentric circles there. So this will help us look through a couple of these other constraints here to learn how to use those. So for starters, what I'm going to do is I'm actually going to just draw straight away a construction line from the center going up. And I'll just hit that little green check mark. And that just gives me a center line reference to go off of. And I don't think there's a way to make that. Yeah, no. Okay, so what I'm going to do is I'm going to start drawing this now as best I can. And what I'm actually going to do is I'm going to draw half of it. And then I'm going to make it mirror across to the other side to just save myself some time. So for starters, you can see here that we've got this arc that has a radius of 10. We can actually leave that part for last. I'm actually going to start with this straight section here. So I'm going to go just straight down, turn off my construction, straight down, and let's see if this does let me do the arc. I don't know if it will. Okay. Because this has radiuses in it, I'm actually going to draw a point, and then this one will be an arc. And we'll go ahead and start with that. So straight line, straight line, straight line. Then comes the arc. So I'm going to hit the green check mark. I'm going to switch to an arc, which I'll just do a 3-point arc, which means I click one point here, the point where it's ending, and then I just give it a little bit of a bend there. Then I'm going to connect that to what appears to be another arc and another arc. So in this case, with this one, I will just draw a straight line that is going to turn into another arc, which is going to be a 3-pointer like that. And the reason for this is in these two, and we'll talk about that in a second here. I'm going to go ahead and do the fillet. And the reason I decided to draw it like this was to show how to use the fillet. So fillet is where you are taking one side and the other side and you're rounding it. So same thing with this one, and that one will also be a fillet. I believe. Oh no, that's part of the same. So actually, this one will be a fillet. This one will be a fillet, and this one will be a fillet. Okay. Nope, didn't get the last one in there. Let's try that again. Enter. There we go. And what we're going to do here is we're actually going to delete that extra line there and drag that up to that point. Okay, so far so good. Do those flow straight into each other? It's kind of hard to tell. It says radius 6, radius 7. So this needs to be 7. You can see here now it's going to start scaling. So this is where I need to kind of adjust everything before I put any more dimensions in. So this straight line needs to come up here. So that curve's coming down. It's got a little bit of a straight. This is going to curve around like that. I'm going to leave that straight line in there for now, just until I get the rest of my dimensions in. I'm going to drag this out. You can see it's kind of flipping out there a little bit. This one down here is probably, we can infer that it's the same radius as this one up here. So this one is also going to be 7. And I'm fairly certain this line doesn't exist and that this bridges straight into that. Yeah, okay. So that's a good starting line geometry here. And the only thing I'm missing is just the top piece here. And I guess we can go ahead and create an arc for that one as well. So there, there, and there. Just like that. And I'll drag that center line over. Make sure that it's coincident with the center line of the whole thing. Okay, and then now what we're going to do is, firstly, before I start adding dimensions, is I'm actually going to fix some of these geometries here that you can see. So in this case, where these two arcs are coming together, notice how it creates kind of a point there. Not only there, but also over here, those look pretty ugly. The reason for that is because those need to actually be tangent. And so what tangent does, besides just having a straight line up with a curve, is it allows two curves to continuously flow into one another. So if I select both of those and I say tangent, it will match up the curvature of both of those to one another. Oops, and I just got my... There we go. So I'm going to do the same thing over here. Take those two and make those tangent. Okay, so I've got those cleaned up. And the only other thing I need to do down here is also drag this to the center. So now we're basically symmetrical. So what I'm going to do is I'm going to define everything that I can, and then I'm going to mirror across the information that I don't have that's on this side that's not on this side. So we'll start with the top. That makes that 10. So go ahead and make this have a radius of 10. And what else do we have? 6 for this one. Oh, gotcha. Because this, if you notice, that was just inferring me, and I'll go ahead and show it there again real quick. This is where you get a warning that's talking about over-defining something. And in this case, they call it over-constraining the sketch. The reason for that is it's having conflicting information. So I'm trying to dimension it, and if you have a keen eye, you'll notice why I can't. Is because there is an equal applied to it, meaning it already is 7 because it's equal to the one that is defined. If I hit OK to make it a driven dimension, it will give it a parentheses here. And what that means is it's purely a reference. That means I can't change this dimension, but if I change this one to be 6, it will change that one to be 6, and this is just in letting me know what that is. But you don't need to add those. It's just nice in some cases to add in reference geometry so you know what you're looking at. So what we'll do is we'll go ahead and delete that equal, change this to 7, and then go ahead and make this one 6 so that it can be its own thing. So that one's going to be 6, that one's going to be 7. That one's going to be 7. And we know that this arc has a radius of 40. So we're going to go ahead and add in 40 for that. And what else do we know? It looks like that's about all we can kind of imply off of what we have here. So what I'm going to go ahead and do is I'm going to create a mirror. And what it asks me for is the mirror line and the objects. So we are mirroring it relative to this. And then what we are, the objects that we are, and you can see I'm clicking to select these different selections here. The objects are going to be this line, this line, this line. We'll go ahead and keep that one for now until we know for sure. And that's it. So I hit OK. So now we have lines on both sides there that are nice and defined. And I can take those 2 points, make those coincident, and take those 2 points, make them coincident. There we go. And now if you notice, as soon as I did that, it's shaded in the inside. That just implies that it is fully enclosed. All right, we're going to go ahead and add in our circles and our slot. So I'm just going to go ahead and add those in willy-nilly. And if you noticed, they are located on the same center points as these radiuses. So all I really need to do is just place them where those are, like so. And then I'm going to place a bigger circle here and a smaller one there. And then lastly, we have a slot. So I'm going to do create slot. And we'll do a center to center slot. We will base the top of it on the center of this top part, and the bottom of it has its own So we'll do something like that. So I'm selecting, and then showing the width of the slot there. So now I've got my slot. Still showing all blue. No surprise there. And what we'll do now is, I know that these are vertical relative to one another. Same thing over here. I think it should have automatically done it, but I'm going to just add it anyways. See if it gives me grief. Yeah, it looks like that's over defining it. This one and this one should be horizontal. Okay, so that is over defining it. Perfect. So that just means that these are already constrained like I want them to be. And these are supposed to be there somewhere. And yeah, let's go ahead and start defining that. So 30 is the distance between. Notice that that's 15. So when I do 30, it's going to be quite different than what I've got shown. So that makes me need to drag some things here. Okay, so we got 30 between those and 16 for that and 10 for that. So I'm just kind of working my way around. So 10, 16. Again, I'm just going to drag these. I'm probably going to leave this one inside just because it'll keep it a little cleaner, and I might drag that one out there as well. And this to here is supposed to be 30. And then this relative to here is supposed to be 55. Okay. Looks like we've got radius 10, radius 5. So radius 10, we'll make this have a diameter of 20 and diameter of 10. So when you do arcs, they come up as radiuses, and when you do complete circles, they come up as diameters. If for whatever reason you want to display it as a radius to make sure that you're doing it correctly, you can right-click it and do toggle radius. Right-click it and toggle radius, and then it will display it as a radius instead of diameter. Okay, and the other thing we needed to do is still figure out where, oh, you can see that my sketch there is breaking. So we're just going to undo that to make sure that we're still holding all right. Is we need to define that those are I think it's just trying to get me to basically make these equidistant from where this is located. So to do that, I'm going to actually add in another construction line here, and I'll go ahead and just place it across that circle there. And I want this and that to be coincident, so that is passing through the center. And then what I'm going to do is I'm going to draw a couple lines, one from there to there. Actually, I don't technically need that line. Wow, it is really struggling with that. It's very interesting. I don't know why it struggled so hard with that. All right, actually I can just take this circle, this line, and this circle and make those symmetrical. I should be able to. Symmetrical. Okay. So what are we missing? Is everything there? Not quite. So the only other thing here is we can assume that this is equal to this just because this whole thing is kind of like a square. So I will just go ahead and take that and that, make those equal. And now we should have a fully defined object. Oop, definitely not. So not sure where the memo got lost there. Oh, you know what it is? I bet you it's these flats. So if I delete those flats and I say this and this are supposed to be coincident. No, except for it's gonna break that side, huh? Well, that's a fun. I'm glad I'm capturing this because sometimes you all will experience things like this, where stuff just breaks and it's not happy, and sometimes that sort of thing happens. So you just kind of have to continue to problem solve. So I'm going to make those tangent, make those, make sure they're tangent. You tangent, you good? Okay, overdefined, perfect. Okay, and are you happy down here? I'm going to make sure that those are tangent, just for whatever reason, in case it's not. Okay, that's still telling me it's overdefined. So what on earth am I missing? I'm gonna just go ahead and step out on a limb and just say that this part of the arc here needs to be vertical relative to that part. Okay. Anything else moving around? Looks like it's okay. Okay, so then what I'll do, just to finish it off, is I'm going to go ahead and just take the center point of where everything is being dimensioned off of, which is right there. And I'm going to take that, I'm going to hold, click my origin point, make those coincident. Yes. The only thing I did not do was define how big these circles are. So those are a radius of 4 or a diameter of 8. So we'll go ahead and just hit 8. And make sure that these and these are equal. And this one is equal. Perfect. So now you can see that everything is turned black. I'm going to go ahead and fix where all my dimensions are so I can see where everything is nice and clearly. All right, and that is fully defined. So that one is a little bit trickier there, and you could see where I was running into some issues, and you may run into some issues as well with yours. Hopefully yours will go smoothly, but in some cases it takes some troubleshooting. The way that I like to kind of, what is it called? Like an analogy of defining a sketch is it's kind of like Sudoku, in which you have some of the pieces and you have to kind of infer and try to come up with answers that make sense and use the information that you have to figure out the information that you don't have. And with that, you should be able to fully define stuff. There is always enough information here. It just may not be as simple when you're trying to recreate it. So basically, that's what we're going to be doing there. It does show that it is undefined, and the reason for that is because of my construction line. So what I recommend if you do have floating construction lines like this is just go ahead and snap it to a point on your sketch, just to make sure that the whole thing is fully defined and you don't lose any points. And that was what that was. So now you can see the lock is on it. It's fully defined. I hit finish, and I'll call that exercise 2. And now we've got both exercises. I can just go ahead and hit the little eyeball, and now you can see I can see those 2 sketches. So that's what I'm expecting for your first assignment this week. Is it's going to be a collection of CAD drawings similar to the ones that I was using here. Your job will be to sketch those, play around with your constraints and your dimensioning tool, learn how to use those, and save each exercise as a sketch, name it, which exercise it is, and then save this file. I'll go ahead and just hit save as your last name underscore, and we'll call this particular one where we're saving it the basic sketches exercise. We can just call it BSE for this week. So Patterson is my last name, underscore BSE. and then we'll be saving it in this folder, and we'll go ahead and just hit save. So now over here in the folder, you can see my file has saved there. Okay, so with that, let me know if you have any questions, and I will go ahead and see you guys on Wednesday and answer any questions that you might have, or any sort of thing like that. So have a good week.